Finally went live. All right. We'll start in a few seconds. Hey, it's 8 o'clock. We'll be in section 6.5 again, looking at the application problems or word problems. So when working on these, they're called application problems. When working on them, read the problem. If you don't understand the problem, then chances that you'll solve it are pretty slim. So you have to read the problem. You might need to read it more than once. Identify what needs to be found. Assign variables for what needs to be found. And then use the given information and the variable assignments to formulate an equation. And then solve the equation and check the solution. Okay, so we'll look at a bunch of examples. The first one, the product of two consecutive even integers is 224. And then it says find two sets of solutions. Okay, so let's think about what this is saying. The product of two consecutive integers, product means we're going to multiply two integers that are both even integers, and they're referred to as consecutive even integers. So can you give an example of a pair of consecutive even integers? Well, 10 is an even integer, and 12 is the next one after 10. So we would say, or we could say that 10 and 12 are consecutive even integers. Since the product is positive, the two integers could both be negative, because a negative times a negative is a positive. So negative 10 and negative 8 that's an example of a pair of consecutive even integers. But do you have a suggestion for how to represent two consecutive even integers algebraically? Since we don't know what those two integers are yet that have a product of 224, it would help if we could represent them algebraically using a variable. Well, there's more than one way to do it. One way to do it is to say, if x is an even integer, then the next one larger than that is x plus 2. So, for example, if x is 20, then x plus 2 is 22. So those are consecutive even integers. Okay, this is one way to use a variable to represent an even integer, and then the next even integer after it, just add 2 to it. Okay, so now what do we do with our variable assignments? So I'll write out a little bit more here. Let's let x and x plus 2 represent two consecutive even integers. Okay, then in part 4 of our step-by-step procedure, use the given information and the variable assignments to formulate an equation. So in the problem, it says the product of two consecutive even integers is 224. So I can use the given information and my variable assignments to write down an equation. So any ideas on what that equation should be?
Would it be x times x plus 2 equals 224?
Yeah, that's right. The product of the two consecutive even integers is 224. Product implies that we are multiplying. So if we multiply x times x plus 2, this represents the product of two consecutive even integers, and we're told that that's equal to 224. So there is our equation, and now we solve it. The left-hand side is factored, but the right-hand side is not 0. So what we want to do, we want to multiply x times x plus 2 to get x to the second plus 2x equals 224. And then we'll solve this equation by factoring. We want one side to be 0, so we subtract 224 from both sides, and we get x squared plus 2x minus 224 equals 0. Okay, and we learned a thing or two about how to solve quadratic equations. That's what this is. This is a quadratic equation in the variable x. The right-hand side is 0, so we want to factor the left-hand side. So let's use the AC method. We multiply the coefficient of x squared, which is 1, times the constant, which is negative 224. So 1 times negative 224 is negative 224. And we want to find two integers that have a product of negative 224, but add up to positive 2. Okay, so if the product of two numbers is negative, one must be positive and one must be negative. And if they add up to positive 2, then the one with the largest absolute value is positive. Okay, so let's practice our systematic approach to finding the numbers. So we'll pick pairs of integers so that the one with the largest absolute value is positive. So negative 1 and positive 224. And then after that, negative 2 and 112. Those add up to 110. Negative 3 is not a factor. Negative 4 times 56. Negative 5 is not a factor. Negative 6 is not a factor. But negative 7. So negative 7 times 32. Those add up to 25. Negative 8 times 28. Okay, negative 9 is not a factor. Negative 10 is not a factor. Negative 11 is not a factor. Negative 12 is not a factor. Negative 13 is not a factor. But negative 14 times positive 16. And negative 14 and 16 add up to positive 2. So we'll factor this using negative 14 and 16. So we transform the trinomial into a quadrinomial. So we have x squared minus 14x plus 16x minus 224 equals 0. And then out of the first two terms, we factor out x. So we get x times x minus 14. And then out of the third and fourth terms, we factor out 16. And we get x minus 14. Then we factor out x minus 14 and x plus 16. This equation has two solutions. One is positive 14. The other one is negative 16. Okay, so remember what our variable assignments are. One of the numbers is x. So you can see how we're going to get two pairs of solutions. So first, when x is 14, the other solution is x plus 2, or 16. So this is one pair of solutions. 14 and 16 are consecutive even integers that have a product of 224. But we have another pair when x is negative 16, x plus 2 is negative 14. So negative 16 and negative 14 also satisfy the problem. They are two consecutive even integers whose product is 224. Okay, the next problem, number 2. This one says a ball thrown upwards from a roof, or from the roof of a building, is h of t equals negative 16t to the second plus 13t plus 48. And the height of the ball is measured in feet above the ground after t seconds. Chances are you've never seen an equation like this. This is a function. It's called a function. So the idea is if t is the number of seconds after the ball is thrown upwards, then the height of the ball after t seconds is found by replacing t with the number of seconds. So for example, when time t equals 0, which represents the instant that the ball is being thrown upwards, its height above the ground is 48 feet. If you replace t with 0, you're just left with 48. After 1 second, what's the height of the ball 1 second after it's thrown upwards? So when t equals 1 second, the height is found by replacing t with 1 and then doing the arithmetic. So 1 second after the ball is thrown upwards, the height of the ball is negative 16 times 1 to the second plus 32 times 1 plus 48. So we just do the arithmetic. Negative 16 plus 32 is 16. 16 plus 48 is 64. So that's how this works. If you want to find the height of the ball after t seconds, then just replace t with that number of seconds and do the arithmetic to find the height of the ball. Well, this height function for the ball will only work for certain values of t, because in just a few seconds, the ball is going to hit the ground, and then the function is of no use after that. Okay, so this says find the zero of the function. So I should explain what that is. The zero of the function is the t value that makes the height equal to 0. Okay, so in general, the t value, or the zero of a function, is not when t equals 0, although it could be for a particular function. It's not in this case. The 0 is the t value that makes the height equal to 0. It might kind of seem backwards, but that's how that word is defined. So this says find the zero of the function, which is the number of seconds it takes for the ball to hit the ground. Okay, so when the ball hits the ground, what will the height above the ground be?
0.
0. Yeah, when the ball hits the ground, it's 0 feet above the ground. So to answer this question, we replace height, which is what h of t represents, replace that with 0, and then solve the equation. So just a little bit, you're going to encounter this word in the Newton software. So it's helpful to know what that is. Okay, so the 0, a function could have more than one 0, but we're looking for a 0 that's a positive value of t. So the 0 of h of t is the t value that makes h of t equal to 0. Okay, well, since h of t is defined to be negative 16 t to the second plus 32 t plus 48, we replace h of t with 0, we get this equation, negative 16 t to the second plus 32 t plus 48 equals 0. So solve this equation. This equation has two solutions, but one of the solutions for t will be negative. And in the context of this problem, a t value that's negative doesn't make sense, because as far as I know, we can't go back in time, right? Time is not negative. Time is only 0 or positive. Okay, so we know how to solve this kind of equation. We solve by factoring. One side is already 0, and we can factor negative 16 out of each of the three terms. So my advice is, if you have a quadratic equation in standard form, This is a quadratic equation in the variable t. And if the coefficient of the t squared term is negative, then my advice is to factor the negative of the greatest common factor, because in my opinion, that makes the arithmetic easier. Okay, the greatest common factor is 16. So if we factor negative 16 out, we'll get negative 16 times t to the second minus 2t minus 3. Since this is an equation, we can divide both sides by negative 16 just to get rid of the clutter that's in the way. The negative 16, we can ignore that. We just want to know what t values make t squared minus 2t minus 3 equal to 0. Remember, you can divide both sides of an equation by the same non-zero number. So I'll just make a note that that's what we're going to do here. Divide both sides by negative 16. Okay, when we divide the left-hand side by negative 16, we're just going to be left with t to the second minus 2t minus 3. On the right-hand side, 0 divided by negative 16 is still 0. Okay, now we factor t to the second minus 2t minus 3. Okay, let's use the AC method. 1 times negative 3 is negative 3. Two integers that have a product of negative 3 and add up to negative 2. They are 1 and negative 3. So the same two integers that we have, 1 and negative 3, have a product of negative 3, and when you add them, you get negative 2. So we'll transform the trinomial into a quadrinomial. And I'm going to write t to the second minus 3t plus 1t minus 3 equals 0, and then factor by grouping. Out of the first two terms, t to the second minus 3t, the greatest common factor is t, and then the binomial is t minus 3. Out of the third and fourth terms, we can factor out 1. When you're doing this factoring by grouping, it's important to write plus 1 times the quantity t minus 3. We don't want to forget the t plus 1 part. Okay, then we write t minus 3 times t plus 1 equals 0. This equation has two solutions, but for this problem, only one makes sense. T equals 3 seconds. The other one, t equals negative 1. T equals negative 1 doesn't make sense because time starts at t equals 0. So the answer that we want is 3 seconds. T equals 3 seconds. You can verify by evaluating this function when t equals 3. The notation for that, if you replace every t with 3, then h of 3, because I replaced t with 3, you can do the arithmetic. It's negative 16 times 3 to the second plus 32 times 3 plus 48. And it turns out that that will be equal to 0 after doing the arithmetic. All right, let's move on to the next problem on the next page. This one says the hypotenuse and the longer leg of a right triangle are 9 feet and 7 feet longer than the shortest leg, respectively. Find the length of the three sides. It's not required, but it is sometimes helpful just to draw a right triangle. And in case you haven't encountered the terms before, we've talked about right triangles already this semester, but for a right triangle is a triangle with one 90-degree angle. That means the two legs are perpendicular to each other. The hypotenuse of a right triangle is the longest side. It's the side opposite of the right angle. And the two other sides, the two sides, neither of which is the hypotenuse, they are referred to as the legs of the right triangle. So a right triangle can have two legs that are the same length, or they don't have to be the same length. Okay, so in this one, we're told that the hypotenuse and the longer leg are 9 feet and 7 feet longer than the shortest leg, respectively. So find the lengths of the three sides. So what'd you come up with? Well, after a while, we're going to apply the Pythagorean theorem. So let me just remind you of the Pythagorean theorem. If the length of the hypotenuse is c, and if the lengths of the two legs are a and b, then the Pythagorean theorem says that if you add the squares of the lengths of the two legs, that's equal to the square of the length of the hypotenuse. So we're going to use the Pythagorean theorem, but we need to make variable assignments for our particular right triangle. So any suggestions? Any suggestions on the variable assignments for our right triangle for the hypotenuse, the longer leg, and the shortest leg? Okay, here's a general strategy, not just for right triangles. So I'll write short leg, long leg, and hypotenuse. So in this particular problem, both the hypotenuse and the longer leg of the right triangle are described in terms of the shortest leg. So if you wanted to write two sentences, you could say the hypotenuse is 9 feet longer than the shortest leg, and the longer leg is 7 feet longer than the shortest leg, right? So since the hypotenuse and the long leg are described, each is described in terms of the short leg, it's going to be simpler in this case to assign a single variable for the short leg. So if I say that the short leg is x feet, then I can represent the hypotenuse and the longer leg in terms of x. So we're told that the hypotenuse is 9 feet longer than the short leg. So if the short leg is x feet, then how do I represent the length of the hypotenuse? How much? Yeah, x plus 9 feet. Because the hypotenuse is 9 feet longer than the short leg. And the long leg is 7 feet longer than the short leg. So x plus 7 feet represents the length of the longer leg. And if you want to label the drawing, you could say the short leg is x, the longer leg is x plus 7, and the hypotenuse is x plus 9. Okay, then we apply the Pythagorean theorem to this right triangle. So we'll square the length of the short leg, so we get x squared. We add that to the square of the long leg. The long leg is x plus 7. So we have to square the binomial x plus 7. And then that's equal to the square of the hypotenuse, which is x plus 9 squared. Okay, so make sure you remember what it means to square something or to raise something to the second power. So there are common mistakes made when raising a binomial to the second power. So you'll want to make sure that you don't make that mistake. So let's write this in a little bit of detail. We'll just leave the x squared the way it is. And what does it mean to raise the binomial x plus 7 to the second power?
X plus 7 times x plus 7.
Right, it means x plus 7 times x plus 7. And then to raise the binomial x plus 9 to the second power means x plus 9 times x plus 9. Okay, so continuing, we get x to the second, and when we multiply x plus 7 times x plus 7, we multiply x times the binomial x plus 7, so we get x to the second plus 7x. And then we multiply 7 times the binomial x plus 7, so we get plus 7x plus 49, because 7 times 7 is 49. And then on the right-hand side, we multiply x plus 9 times x plus 9. So x times x is x to the second, plus x times 9 is plus 9x. And then plus 9 times x is plus 9x again, and then 9 times 9 is 81. Okay, so now we combine like terms. The left-hand side becomes 2x squared plus 14x plus 49. And the right-hand side is x to the second plus 18x plus 81. Okay, we want to solve this equation, so what should we do now? So how have we been going about solving equations the last couple of days? we want one side to be 0. We don't have that yet. So we can make the right-hand side 0 if we subtract x squared from both sides, subtract 18x from both sides, and subtract 81 from both sides. So when we subtract x squared from both sides, 2x squared minus x squared is x squared. And on the right-hand side, we'll have no more x squared terms. Then subtract 18x from both sides. So on the left-hand side, 14x minus 18x is negative 4x, so we write minus 4x. And then subtract 81 from both sides. 41 minus 81 is negative 32, so we write minus 32. And the right-hand side is 0. And then we factor the left-hand side now that the right-hand side is 0. Okay, so I can just write down the factors, or I can go through the more lengthy process of using the AC method to factor the left-hand side. So you should do whatever it takes. If you need to go into more detail by using the AC method, then go ahead and do that. I'll start to explain what is called the abbreviated AC method. The abbreviated AC method can be applied when one side is 0 and the coefficient of the x squared term is 1. Okay, so 1 times negative 32 is negative 32. Two integers that have a product of negative 32 and add up to negative 4 are negative 8 and positive 4. So just note, that's the first part of the AC method, finding two integers that have a product of 1 times negative 32 and add up to negative 4. So negative 8 and 4 are the two integers. So the abbreviated AC method, which can only be applied when the coefficient of the x squared term is 1, we can write down the two factors. Okay, one of those numbers is negative 8, so one of my factors is x minus 8. The other factor is positive 4, so my other factor is x plus 4. So all I did was bypass the transforming the trinomial into a quadrinomial and then factoring by grouping. And we just went directly from finding the two integers, negative 8 and 4, to writing the two factors, x minus 8 times x plus 4. Okay, so this equation has two solutions. One is positive 8, and the other one is negative 4. But in this problem, the solution that is positive is the one that we want. Because normally, we don't use negative numbers for lengths of sides of polynomials or triangles in particular. Okay, so the short leg is 8 feet. So we can say the short leg is 8 feet. The long leg is 8 plus 7, or 15 feet. And the hypotenuse is 8 plus 7, or 8 plus 9, which is 16 feet. Okay, the next problem. So let's read it. I'll give you a minute or two to work on it. See what we come up with. This one says the product of two integers that differ by 4 is 221. So find the two integers. So on this one, we'll get two pairs of solutions. One pair, each will be positive in one pair, and in the other pair, each will be negative. That seems to make sense because if you multiply two positive numbers, you get a positive number for a product. If you multiply two negatives, you get a positive number for a product. Okay, so the product of two integers that differ by 4 is 221. Okay, variable assignments. Well, we're going to multiply two expressions that each represent in integers. So we're not going to start by multiplying, we're going to start by representing those two integers based upon this information. The two integers differ by 4. So what does that mean? Can you give an example of two integers that differ by 4? How much? Okay, yeah. One that I was thinking of, 17 and 21. I mean, there's infinite number of examples, but as long as the difference between the two integers is 4, but how do we represent that using variables? Well, if x is one of the integers, then the other one, I can use x plus 4. This is one way to use the variable assignments. It's not the only way, because if I wanted to, I could write x and x minus 4 if I prefer. But just do it one way, one or the other. Okay, so x and x plus 4 differ by 4, and the product, x times x plus 4, is 221. Product means we multiply. So here's our equation. And to solve it by factoring, we want one side to be 0. So we have to multiply x times x plus 4 to get x squared plus 4x. And then we subtract 221 from both sides. And then we solve this quadratic equation. We can use the abbreviated AC method because the coefficient of x squared is 1. So if we multiply 1 times negative 221, which is negative 221, we want to find two integers that have a product of negative 221 and add up to 4. Okay, so at the extremes, we want the one with the largest absolute value to be positive, because they have to add up to positive. So negative 1 times 221. Negative 2 is not a factor. Negative 3 is not a factor. Negative 4 is not a factor. Negative 5 is not a factor. Negative 6 is not. Negative 7 is not. Negative 8 is not a factor. Negative 9 is not. Negative 10 is not a factor. Negative 11 is not a factor. Negative 12 is not. What about negative 13? So does 13 divide into 221?
17.
So 5, 6, 7, exactly, right? Okay, so negative 13 and positive 17. Those differ by 4, and their product is negative 221. Okay, so using those two integers, negative 13 and 17, remember the abbreviated AC method? Since the coefficient of x squared is 1, one of those numbers is negative 13, so I can write x minus 13. And for the other factor, I can write x plus 17. So we're going to get two pairs of solutions for the two integers that differ by 4. So one value of x is positive 13. The other value of x is negative 17. And then x plus 4 is positive 17. And then the other pair is negative 17 and negative 13. Okay, so one pair of integers that differ by 4 and have a product of 221 are positive 13 and positive 17. But we have another pair of integers that also differ by 4, negative 17 and negative 13, and their product is also 221. Okay, there's a little bit more than 2 minutes left. This problem, number 5, is similar to the one that we just did. It's just that this time the two integers differ by 18. Let's look at this one for a couple of minutes, number 6. The area of a rectangle is 432 square feet, and the length of the rectangle is 6 feet longer than the width. So find the length and the width. Okay, so we have a width and we have a length. And we're told that the length is 6 feet longer than the width. So if I assign the width to be x feet, and the length of the right triangle is 6 feet longer than the width, then we represent the length by x plus 6 feet. And then remember how to find the area of a rectangle. If you multiply the length times the width of a rectangle, you get the area. So our equation then will be x times x plus 6 equals 432. So like we've seen before, we multiply these two factors to get x squared plus 6x, and then we subtract 432 from both sides. And then we factor the left-hand side. So it won't take too long to find the factors of that, but We're about out of time for today. Keep in mind, 1 week from today is test 2. Later today, I'll be sending a test 2 review sheet, and we'll have a couple of days to review for the test next week on Tuesday and Wednesday of next week. Okay, that's all for today.